Okay, so we're talking about graphing sine and cosine. So last couple days we have talked about what basic sine and cosine look like, and we've covered the words amplitude and period, right? We've covered those two words. So that's all we're going to review. So sine, remember, it starts at 0, 0. It goes up, down, up. Okay? This distance right here, that is the amplitude. This distance right here, that is the amplitude. Okay? How long it takes to repeat, that is called the period. Okay? For cosine, cosine starts at 1 and it goes peak, valley, peak. Okay? Again, this right here is the period. Same thing, this is the amplitude. So on your basic sine and cosine, the amplitude equals 1. Now just to prove it to you, the number in front here is a 1, right? 1 sine x, 1 cos x. So that's why the amplitude is 1. It matches that number in front. Now, you're going to get an equation where there's going to be a number inside here. We call this the b value. Now, the b value messes with the period. Okay? So your period is always going to be 2 pi divided by that b value. So 2 pi divided by that number. So for example, if there is a 2 here, so then you would go 2 pi divided by 2, so then you would get out 1 pi. So that means from start to finish, it takes 1 pi. That's the length of the period. And that's what we did on Thursday. We just did a bunch of examples on A and B. So I can print this page out for you guys, okay? So what we're going to do today is there's 2 more examples in the notes that we didn't get to on Thursday, because to say the least, I was a wee bit distracted. So we'll do it today, and then I have to leave for about 25 minutes or so. And so you're going to get some work time on this. And then when I come back, we'll keep doing more examples. Okay. And this is all we're going to do today and tomorrow. We're just going to keep doing examples with these graphs. So what I need you to do, that's weird. Go to page 371 is where we're at. Is that page 371? 3 sine 2.5? No. Okay, where is this one? I thought I had gone through and found all of them. Clearly I'm mistaken. Okay, 370. Where? It's not on my 370. Okay, so why don't I just do this one with you guys and then I'll print it out for you. Okay? So just look up here and follow along. Okay? So can we just do this one together then? And okay, and I'll just print it out for you. Okay. Okay, so here's the equation right here. Okay. So this is the A value. This is what we call the B value. Okay. Why are they called A and B? It's just because when we do the regression on Thursday, like the list 1, list 2, the equation that you're going to create is called, the numbers that you're going to plug in are A, B, C, D. So it's just to match that. So what mode should the calculator be in? Okay, so the mode is always going to be in radian mode every time. So the default in this unit is radians. Okay, so on your calculator, let me just clear all this out. I was just doing stuff with my grade 10s. So if you hit mode, you want to make sure that radian's highlighted. Now, If you've been going, oh crud, I've been in degree the whole time, does that mean everything I've done in math is wrong? No. The mode only matters if you happen to be hitting one of the sine, cos, or tan keys. So if you're hitting sine, cos, or tan, if you're hitting any of those keys, the mode matters. If you're going 3 plus 7 times 2, the mode is irrelevant. So for you guys, when you walk into the diploma, your calculator is going to be cleared. When it gets cleared, it automatically gets put into radian mode. You're just going to leave it there. You don't ever have to worry about changing the modes. Okay, in 30-2, we leave the mode as a radian set. Okay, so what we're going to do is before we even plug this in, I want to talk to you about what this picture should look like. Okay, so this number in front here, this is the amplitude. Okay, so for sine, our x-axis is the halfway line. We are going to go up to 3 and down to -3. Okay, so that's the first thing. That's what that amplitude does, is it's from the halfway line, you're going to go up 3, down 3. Okay, this right here, this is the tricky one. Period. And period, remember, is how long it takes that wave to occur, right? Like how long it takes to happen. We're going to go 2 pi, and we're going to divide it by this b value. Okay, so on your calculator, if you go leave off the pi, so if you go 2 divided by 2.5, you get out 0.8. So if you go math 1, you get out 4/5. So the proper way of writing the period is 4/5 pi. That is not going to make any hill of beans of sense to you, right? It's like the first time I introduced a log. You're like, what the heck is this, right? But when I showed you how to convert it to an exponent, crystal clear. So what a lot of kids find handy is if they actually convert it using the pi key. So instead of punching this in, we're going to go 2 pi divided by 2.5. You actually punch 2.5. And you get out the decimal. So you get out about 2.51. So what that means, it means, so sine starts here. It's going to go up, down, back. It's going to take about 0 to 2.51 on the x-axis. 4 pi over 5 is exactly 2.51. If I show it to you, so you can either plug it in as 4 pi over 5, or you can punch it in as 4/5 pi. It's the same thing. This pi, it looks like it's on the bottom. It's not. It's on the top. What it is this. 4/5 pi. So either way, you get 2.5. All I'm saying is that in 30-2, 4/5 pi doesn't mean anything to you, but 2.51 matters, right? So from start to finish, you're going to go from 0 to 2.51. Why do you care? A calculator can only find what it can see. Okay, so you would make your Y window settings, maybe you're going to go from -5 to 5, and maybe you're going to go from 0 to 5, right? So that you can see the wave. Because if you, let's say, went from 0 to 100, it's going to look like a heart attack on your little page. Here, I'll show it to you. So if we plug this thing into Y1, so we go 3, we hit sine 2.5x. So you just do that. Okay. So for my window, if I have no idea, let's say I go to 100 because I have no idea what my x should be. Like I have no clue. Look at this thing. It's really cool, but it's a heart attack on your screen. Whereas if you know what the window setting should be, so I'm going to go from 0 to 5, and I'm going to go from -5 to 5, now I get those nice waves. So it's just like what we've done in our other units, right? Where you have to think about what your x min and x max should be, your y min and y max. It's the same thing with this. but you have to understand the A and the B and how they affect the picture in order to be able to do the window setting. Okay. Okay, so I just wanted to talk about that. We're not going to worry about that stuff. Okay. Okay, I think this is the one that you have on the bottom of page 371. Okay. Okay, so page 371. So it says here, this is a sine bx. Okay, so first off, it says the word sine. So we know with sine, we're looking for that period. Well, sorry, that shape. Okay. Can you see that shape in multiple places on the picture? Like, do you see lots of waves? Okay. What you want to do, and here's the key to this, is you want to pick the wave that's closest to the y axis. Pick the wave that is closest to the y axis. So here's your y axis. Here's where I'm going to start. And I'm going to go up, down, up. What I am then going to do, so just this is, now I can do this on my smartboard because it's a handy little feature. What I can do is I can then change my pen to white. And what I'm going to do is I'm going to go like this. I'm going to erase everything else because I don't need to see it. Now, you don't have that option unless you want to physically white things out, right? That's not an option for you. So what some kids did in the last semester class is they would do this. They would take a highlighter and they would draw a box around the one wave that they wanted to look at, and then they would ignore anything else on the outside of that box. Okay, does that make sense? So you just want to find one wave, and you want to find the wave that's closest to the y-axis. Now, because you're in 30-2, there should always be a wave starting on the y-axis. Okay, it should always start at 0, 0. Okay, so amplitude. So from that middle line, how far up and how far down did you go? 3. So the amplitude is 3. Drag and drop. Okay, so second question is period. Okay, period and B, so period and B are not the same number. And if that is the only thing you remember from the 4 days we spend on sinusoidal, that's what I need you to remember because it's a guaranteed diploma exam question. Period is the length of one cycle. So all you're going to do is look at this picture and tell me how long that cycle is. How long? 1 pi. It went from 0 to 1 pi. See that? So the period is 1 pi. Okay? So for the equation, we're going to go y equals. Now, the amplitude, okay, the amplitude is always the number in front. So I'll say that again. The amplitude is always the number in front. So we're just going to write in a 3. Okay. To find the B value, you have to have this formula memorized because it's not on your formula sheet. I don't think it is. Let me double check. Oh, it's on the formula sheet. Okay, so on the formula sheet, they give you this formula. So that formula is given. Now, I want to find the B value. I don't want to find the period. So what you're allowed to do is you're allowed to swap those two things around. So instead of writing period equals 2 pi over b, you can write b equals 2 pi over period. You can just swap the position of those two things. So I already said my period is 1 pi. So it's Monday morning after grad. If you don't want to think, on your calculator, go 2 pi divided by 1 pi, and you will get out the number 2. Did you get out 2? Yeah? Yeah. Or 2 pi, because essentially the pi's are crossing off, right? So 2 divided by 1 is just 2. So that's why I said you don't have to plug in your calculator, because you should just kind of know that. Okay? But if you want to go on autopilot, the formula works. Okay? My point being is this. You have to read the diploma exam question very, very carefully. So the diploma will, if it asks you for the period, the answer is 1 pi. If it asks you for the b value, the answer is 2. B and period are not the same number. Okay? Okay, we're not going to worry about part C. We're just going to focus on finding these equations. Okay. So I don't know how much we'll get done here, but we'll try to get through this last example here, and then you can have some time to work. So it says the partial graph of the sinusoidal function is shown. So again, this is our graph. Here's the problem, right? Sine is a wave. So what's happened here is here's the start of it. It goes up, down. What's wrong? It doesn't show us the rest, right? So what we're trying to find is we're trying to find this. It didn't give us that part. But here's what you know. This is half the wave. And half the wave went from 0 to 6. So how big's the other half going to be? Another 6. Why is that important? Because of the period. So here's our halfway line. How much up did you go? 3. So the amplitude is 3. How long is one cycle? How long is one cycle? 12, not 6. That is a classic diploma exam question where they'll only give you half the wave, and you have to remember, oh, that's only half. I need the full repeating pattern. So you have to double what you see on your page. So what's the equation? Okay, where does the amplitude number go? Every time. Where does this one go? Right here. You just drag and drop that number down. Okay? For the b value, the formula is 2 pi over period. My period is 12 units long. And it doesn't matter if it's 12 seconds or 12 miles or 12 what, it doesn't matter. It's 12. So if on your calculator you punch this in, 2 over 12 reduces down to 1 over 6, and then you would punch the pi back in. This is what we call the exact value. What the diploma may want is the approximate value. So then you would go 2 pi divided by 12, and you get out 0.52. So then you would write the answer as So you're just going to have to base it on what you see on the page. Okay. This is the approximate. Sorry. Yeah. Or the decimal answer. Okay. It'll want this if it's numeric response. It'll want this for multiple choice. So it's just however it says. Okay, I have to go, but here you go. This is something for you to work on. Okay. Okay, so if we look at number 5. Okay, so it says here, we've got the periodic function. So periodic function, again, just means that it's a wave pattern that repeats and repeats and repeats over a specified time period or specified length of time or length of space. The diploma will use the word periodic and sinusoidal interchangeably. They mean the same thing, okay? So 15.3 sine pi x. So if you're going to be doing this on your calculator, window settings are everything. So this number right here, that is the amplitude. So just as a general, if you were just kind of thinking about this, right? So here's your wave, right? Up, down, up. So it's going to go up to 15.3. Oh, hello. It's going to go up to 15.3 and it's going to go down to 15.3, right? That's the amplitude. So that tells you your Y min and Y max. So if you go up to 20 and down to negative 20. The period is the length of the cycle. So on your formula sheet, you've got that formula. This right here, that is your B value. So you're going to go 2 pi divided by pi. And you get out 2. So that means from start to finish is 2. So if you look at part A of the question, it says, what would you make your window setting to show 3 periods? To show 3 periods, you'd have to go from 0 to 6. Whoops, that's not drawn good, right? Because each one counts for 2. So yes, it's graphing calculator, but you've got to do the manual work first so that you know what to make the window settings in the end. Okay. So that's all I wanted to do on number 5 with you, is just, again, thinking about that B value and the period. Oh yes, so for the window settings, so you would go X. So you always put the min first, the max second, and then the scale. For the Y, you do the min first, the max second, the scale. And they don't care about the scale, they only care about the min and the max. Okay. So look at that funky little wave there. Okay. So it says a student graphed a sinusoidal function. He determined that the maximum value was 250 and the minimum value was negative 250. Okay, so you've got the whole bunch of waves there drawn. So when the question says it has a maximum value of 250, that's the peak. A minimum value of 250 is the bottom. Okay? Okay, so when it talks about the max and min, so we're on page 375. When we talk about the max min, that's the peak and the valley. The next important part here, it says a partial window he used was negative 6.28 to positive 6.28. So what that means, 1, 2, 3, so 1, 2, 3. So that means that this window ended at 6.28 and the other way ended at negative 6.28. I just didn't draw out the whole window. Okay. So here's the key to this. Okay. So if we look at question 7, it says, what's the amplitude? So we know the max is at 250, the min is at negative 250. So how far is it? What's the amplitude? 250. Okay, easy. That is going to be a diploma exam question. Not every diploma exam question is going to be like mind-blowing 14 steps later. Okay, they're just straight up. Okay, so the period. Okay, here's the tricky bit. Okay, so for question number 8. So just focus on this positive part of the graph. Okay, we know that the graph goes from 0 to 6.28 because it told us that in the window settings. Okay, how many cycles have been drawn within 0 to 6.28? Well, there's 1 cycle. There's 2 cycles. There are 3 cycles, right? 3 cycles have been put into 6.28. So that means to find the length of 1 cycle, you're going to go 6.28 and divide it by 3, right? Because there's 3 cycles from 0 to 6.28. So you just have to go 6.28 divided by 3. So that's 2.09. Okay. So that means from here to here is 0 to 2.09. Do you understand how I did that? I had 3 waves from 0 to 6.28. So 6.28 divided by 3. And then don't worry about question number 9. That's irrelevant. So then it says, to the nearest hundredth, the first positive x-intercept. To the nearest whole number, the value of b. Okay. So in order to do, so the first x-intercept is this one right here, right? So we know from here to here is 0 to 2.09. This point is where on the path? It is the halfway point, right? This point is halfway along that wave. So you just have to go 2.09 and divide it in half. So that's 1.05. So this point right here is at 1.05. Okay. And how did it want it rounded? There's hundredth, so 1.05. Okay. And then for number 11 asks you for the b value. So remember to find the b value. The formula is 2 pi over period. Okay. How long is one of the patterns? How long is the cycle? 2.09. So on your calculator, go 2 pi divided by 2.09. You get out 3.01. So what is the b value to the nearest whole number? 3. So if we were to write the equation of this curve, and it didn't ask you for it, but you would write the amplitude is 250, the b value is 3, and there's the equation. Okay? So that's what the diploma is going to kind of do to you with this. It's focus on the amplitude and focus on the period. The key here is period and b are not the same number. B is the number that you need to find the period. Period is the length of the cycle. Okay. So if we go into number 4 here. Okay. Okay, so you guys pass those. This one is for you, sir. So this is pretty much in your notes, but it's not color and it's not pretty. So I'm just making it pretty so it's easier for you to look at. Okay. So here's what we've talked about. We've talked about amplitude. Okay. we've talked about period. It's the length of one cycle. So if I put these two things together, here's my sine wave. So this is the amplitude. This is the amplitude. The period is the length of one cycle. Okay? Now, this thing called the midline. Every once in a while, you'll see it called the median line. You will never hear me call it that. I've always called it the midline. The midline that we have been doing, our midline has been the x-axis. It's the line that divides your peak and valley in half so that you have the same distance up as you have down. Our midline has always been on the x-axis. It doesn't need to be. The midline can be anywhere actually. Okay. So, I don't know if you copied too well, but if you have a highlighter handy, highlight the x and y axis here. Okay. And then highlight one sine pattern. So from here, go up, down, up. So you will see that this sine wave has been shifted above the x-axis, right? It's sitting kind of floating in quadrant 1. So sine just so happens to always start on the midline. Always. Always, always, always. So wherever the wave starts and wherever the wave finishes, that will always be the midline. Always. The amplitude is the distance up, or you can think of it as the distance down. Now there are some formulas that you can use for amplitude and midline. I personally do not use them just because I don't. So there's a formula for amplitude and there's a formula for midline. I just use my eyes. Like the midline divides the hill and the valley into even sized chunks. So if it's not divided in half, I know I've got the midline drawn in the wrong spot. I don't need to use formulas. I can just look at it and know. Okay. And then we still have the length of the period running from here to here. So we still have the period going from here to here. Okay. So if we just kind of review, so if in terms of studying for the, so again, this your unit end on this one is going to be an open book unit end. I talked to you guys about that last week. But clearly the diploma is not open book. So you actually have to learn this. This is the page you need to know. So if you're going to just study something, study this page because it has everything on it. Okay. So amplitude always is a positive number because it is the halfway distance. It's the distance from the middle up. It's the distance from the middle down. So amplitude has to be a positive number. Period is the distance or the length of one cycle. So again, the period has to be a positive number because it's length, it's distance. Okay. The midline, if the midline has gone up, it's going to be a positive number. If the midline's gone down, it's going to be a negative number. It's going to make sense. Okay. So we're just going to do some examples with this just to see how you digest it and kind of go through it all, but we're going to go slow. So we're going to spend all of tomorrow on this as well. Okay, so super slow, nice and steady. Okay, so on the back side, I've just summarized this with colors. Okay, so when you do the equation, the number in front of sine, that's the amplitude. Okay, so you can either think of it as this distance right here, or you can think of it as half the total distance from top to bottom. So you can think of it either way. Okay. B relates to the period. B does not equal period. So on your formula sheet, this is given. Period equals 2 pi over b. If you swap these two around, you get b equals 2 pi over period. Okay, so you can just swap the b and the period depending on what you want. So if you're looking for the period, you go 2 pi divided by b. If you're looking for the b value, you go 2 pi divided by period. And then d is the midline. So the way we write that answer is we write it as y equals d. And I'll talk to you about these ones probably tomorrow. We probably won't talk about these ones yet. Now, just going forward. So notice how I skipped over letter C. We'll briefly talk about letter C tomorrow, but you guys do not need to worry about letter C in Math 30-2. So we'll talk about it, but we're not going to focus on it at all. Okay? Where am I going with this? On Wednesday, so Wednesday is the last lesson of the unit. I'll say that again. Wednesday is the last lesson of the last unit of Math 30-2. You are down to 2 lessons left. It's a good day. Okay? So on Wednesday, we're going to do the list 1, list 2. So I'm going to give you a bunch of points. You're going to put them into list 1 and list 2, and you're going to pick sin reg or sine reg. And the answers for sine reg are going to be shown like that. They're going to give you 4 numbers that you're going to plug into. So they're going to give you a number for C, but we don't really focus on it in this course. But I'm giving you the equation written like that because that's exactly how it's going to appear on your calculator. Okay? Essentially what this is, what we were just doing in the first half of class today was that. I didn't give you this. So that's what we've been doing for like today and last Thursday was just A, B. I'm just adding in the C and D part today. Okay? So, page 379. We're just going to do some examples and then we're going to call it good. Okay? Then we're not going to get through all of them today by any means. So it says, in the diagrams, the sinusoidal function has been graphed with the thin line. So if you have a highlighter, the thin line is the original. So this is the original. The thick line, this is the new. Okay? I would highlight the thick one because that's the equation, that's the one that you're looking for. Okay? So it says, determine if the sinusoidal function graphed with the thick line differs from the original. Is there a change in amplitude? Is there a horizontal phase shift? We'll talk about that here in a sec. Is there a change in period? Is there a vertical shift? Okay, so what I'm going to do is I'm going to write a little table here. So we're going to write original and we're going to write new. And we're going to write amplitude. Okay? So let's look at the original. So the original goes up to 1 and down to -1. So the original has an amplitude of 1. Okay? The midline. So I'm talking about the original here. The original starts at 0, 0 and finishes. So the original has this as its midline, right? Because it starts on the midline and finishes on the midline. And you can also see it goes up 1 and down 1 off of that midline. So the original has a midline of y equals 0, which is the x-axis. Okay? The period. So from start to finish, how long did it take? 2 pi. You okay with that? So that's what we've been talking about. Okay. Do you see where that blue line is drawn? So now focus your eyes on the yellow highlight. Do you see where the blue line is drawn right here? See that? Does that provide you with a halfway line? Is there the same amount of space above it as there is below it? No. So I have to move that midline. Where should I move the midline to? Where it starts and finishes. So it starts here and finishes there. So where's this midline at? Looks like it's -2. Now, on the diploma, they draw graph paper. It's actually on grid. It's not just in a blank space. Okay, so it's easier to see. So now that we know where our midline is, can you now see how far up and how far down you go? How far up do you go from the midline? How much space is there? 1, 2, 3, 4, 5. Looks like. Is that right? So the amplitude is 5. Okay. Does it start at 0 and still finish at 2 pi? Yes. So, did the amplitude change? Yep. Did the midline change? Yep. Did the period change? No. Okay. So what is phase shift? Phase shift is moving your entire wave to the left or to the right. Okay? That's what phase shift is. Phase shift is a movement left or right. So, look at your y-axis. Did your original start at 0, 0? Did your transform start at 0? So phase shift is 0 and 0. They both started on the y-axis. Okay. Okay. We're good? Okay. Use 2 highlighter colors, please. So I'm going to use green for the original. So my original is here. There's my original, right? Because the original is the thin line. I'm going to use hot pink for my, now, hold on, don't highlight the whole thing in hot pink. Wait. You only want to highlight an up, down, up. So for the this one, I'm just going to highlight from here to there. That's my one wave. Everything else I don't care about. Right? You just want to highlight the same shape. Right? You go up, you go down, you come back. I'm just going to show you here. When I go to my pen, okay. I don't care about any of this. I only care about that. Okay, so what you can do on your page is you can draw a box around the purple. So that way your eyes only focus on that. Okay. Look at the green. Does the green start and finish on the x-axis? Yes. Does the purple start and finish on the x-axis? Yes. Does the green go up one and down one? Yes. Does the purple go up one and down one? Yes. Let's do phase shift next. My green starts at 0. My purple starts somewhere over there. So this one has no phase shift. This one went to the right. I don't care how much, it's irrelevant. It just went to the right. It started not on the y-axis. Okay, period. So my green went from 0 to 2 pi. Okay, what I want you to do, put your finger on the very first peak on the y-axis. I've erased mine, that's why I can't do this on the board. Put your finger on the y-axis on the peak. Now, go from peak to peak. So take your finger and go peak to peak. Nope, first peak to peak. So that's 1. Go again, peak to peak. 2. Go again, peak to peak. 3. So how many waves appeared in that 0 to 2 pi? 3. So the period is 2 pi divided by 3 because it had 3 waves appear. Now, does it matter that I went peak to peak instead of like a nice little wave? No, it's irrelevant. It's how many patterns appeared from 0 to 2 pi. So if you punch into your calculator, 2 times pi divided by 3, you get like 2 point something. Okay. So this one has a length of 6.28. This one has a length of 2.09 because it's a third as big. Now it doesn't matter that I went peak to peak and this one is up, down, up. It doesn't matter. It's the same wave. Okay. Now on the diploma, they will not put both pictures on the same graph. They will draw the original on the left and they'll put a brand new picture on the right. And they'll say, this is the original, this is the new. And they might give you a table, right, like this, and they want you to fill it in. That could be a short answer question on the diploma. Okay, where you have to figure out all the properties. They won't ask for phase shift. They'll only ask for these 3. Okay. Okay, we're going to call it a day here. Okay. We'll muck more with the D value tomorrow. Okay, if you want to, if you didn't get too much done, you could do question numbers 1 and 2 on page 384. Okay. And then tomorrow we will just deep dive into this more. We'll just keep doing examples, examples, examples. Question number 2 on page 384 is exactly what I just did with you. It's like a chart, okay? But there's 6 of them, and we just did 2 of them, okay? So we handed that out. We didn't hand the other 2, so those will go back in my closet.